Hello everyone, and welcome to my first video on the BeagleBone Black. And it's also going to be my first video on a series I'm going to do on that I'm going to call BeagleBone Barebone. And by barebone, I mean like bare metal programming. And what that means is that instead of using an operating system, we're going to program the BeagleBone Black like a traditional microcontroller and use it that way. To do that, we're going to use a package from Texas Instruments called StarterWare, and we're going to use that in Code Composer Studio version 6. Just a little bit of an intro. If you're not familiar with the BeagleBone Black, it's a single board computer. Most of the time, most people use a Linux-based operating system on it. You can also use Android, and there's some other options out there, and you can write programs on it in a number of different environments. But what I want to do is instead of using it as a computer, I want to use it as a very capable microcontroller. And to do that, I want to get rid of the operating system and just go directly to programming the microcontroller. And actually, there are three processors in the main system on chip here. The Satara 3358 has its main ARM 8 Cortex 8 processor, and then it has two programmable real-time units that both operate at 200 megahertz. And so with having those three cores, if you will, we can do a lot of different things with it, and we're going to dig in and try to use those. But I really don't want to, while I want all the control, I don't want to have to write assembly. So we're going to start with a package called StarterWare that already has a lot of the low-level code done, and we can use libraries to just write C code. Now to get started, I'm going to skip ahead, or I'm going to skip over some of the real basic stuff, like getting the BeagleBone and things. So really the prerequisites for this video is you need to have a BeagleBone Black, of course. You're going to need a JTAG emulator, and the one that works with Code Composer Studio that I'm going to use, the free version of Code Composer Studio, is the XDS 100v2, and I'll provide a link to this in the video description. You also need to buy and install a JTAG header on the BeagleBone Black. Now, that's going to require some soldering, and it's not easy if you're got a shaky hand. Maybe you want to get a buddy who's good at it or something. It's some fine pins, and you do need to do some soldering, and recommend getting some solder wick too if you're going to do it, because I had to wick off quite a bit of solder that I got stuck in between pins and stuff. So it is possible, but that's probably the hardest part about this, is getting that JTAG installed. Now when you install that JTAG, just keep in mind that you need to remove pin 6 if it isn't already removed, and I'll show you about that a little bit later. Next, you also need to download and install Code Composer Studio version 6, and again, I'll provide a link to these. You will need to agree to some terms, and there's some restrictions on its use, so pay attention to that. You also need to download and install the StarterWare package, as well as, and this is very important, you need to install a BeagleBone Black patch. So it's and you need to follow the instructions that are in the release notes for installing that patch. It's not just as simple as downloading it and sticking it in the folder. Well, it's almost that simple, but follow those instructions. And I'm going to assume that you have some general understanding of C programming of a microcontroller. If you don't, I do have some other videos on the C programming in general using a Raspberry Pi, and I also have some videos that I'm doing on C programming on the Freescale Freedom platforms. And so those might be useful for you to get a little familiar with programming in C. So let's go ahead and move to Code Composer Studio. Okay, when you first open Code Composer Studio, you might get a view that looks something like this. It might also ask you to upgrade your package. Go ahead and do that if you like. I'm also I'm going to use one of the apps from the App Center. I will be using the TI ARM compiler, and I think that's the only other app I'm using out of here. So you can go ahead and install that. Okay, one of the first things we need to do is set up the target configuration, and you need to be in the CCS edit perspective over here. And if that's not showing up, you click on this right here and select it from the menu, and then you go view target configurations, and I already have this set up. I just called it BBB. But if you won't have anything here, if you're just getting started, and so you go up here and add this, just give it a name. It doesn't matter what it is, and then you'll go over here and select first select your debugger up your connection. It already came up with this because I already have it, but it's a Texas Instruments XDS100V2 USB debug probe. If you're using the one that I said to use, and then check BeagleBone Black. And one of the things I noticed that's a little strange is if you go over here under target, it says it's 3359. All my data sheets say it's actually 3358, but it seems to work. If you notice that too, maybe you can tell me why that is. But that's about it. I'm going to close this though. I'm going to cancel because I already have this set up, as I said. No. And go back over here, view target configurations, and you see, oh, I want to get rid of this. Delete that. Okay. This is the configuration that I'm going to use. Okay. Next, now you could browse your example projects here, and you might not see this. In fact, I'm pretty sure you won't. What you need to do if you want to add this to your browser here, click on this and then navigate, or click add and then navigate to where you installed your StarterWare package. And for me, it's down here, right there. Click OK, and it would add it. Okay, I'm going to cancel. Now, what we're going to do here is we're actually going to import a gpioLEDBlink project, but I've noticed if I do it from here, it doesn't work for me, so I'm not going to do that. All right, what I'm going to do is over here, just going to right click, import CCS project, and then I'm going to browse to it. And again, I'm on where I installed my C drive, TI, and right there. And you want to go under the build folder. This is important. You might see different copies of this structure in different places. You go under the build folder, okay? And then it's ARM v7a, CGT underscore CCS, AM335X, BeagleBone, and then click on GPIO and hit OK. And make sure that is checked. Make sure these are not checked. If you check these, this might not work. Or in fact, it did not work for me, and I fought with it a little bit, and it took me a little while to figure out how TI sets this up. But make sure those are not checked, and just hit finish. Okay. Oh, that's because I did this and I deleted it before. Okay, if you get that warning, I'm just going to cancel this. Go to your workspace, and for me, that's let's see, me, users, my name, and it's workspace version 6, and I already had this in here. See, I deleted it from my project view, but I didn't delete it from the disk. So I'm going to delete this from the disk right here. Okay, and now this should import correctly. Back over here, import, CCS project, browse to where it's located, and GPIO. Okay, make sure it's checked. I do not want to have that checked, okay? And then hit finish, like that. And now, if I go over here and double click on this, there I have the C program. Now, I'm going to go ahead and build, well, let me right click first, and I'm going to hit refactor because I just want to make sure it's what this does is it sets it up for the compiler I'm using. And so it's the TI version 5.2.3 compiler. Hit OK, and I think that's about it. We can go over to properties and look at this, just double check, but it's already says it's set up for the BeagleBone, the right probe, right compiler, everything linker is good, and so okay. Okay, next I'm going to go ahead and build this project, and I can do it one of two ways. I can right click and hit build project, or I can hit the hammer here. I'm just going to show you right click, build project, and it's going to build correctly for me because I've already built the libraries that this depends on. But if you're doing this for the first time and this is all you've done, this will not build. You'll get some errors and it'll look something like this. It will tell you that it can't find these libraries, and that's because the libraries in StarterWare are not built when you install them. So you actually have to build all the libraries before you can use them. To do that, we actually will import those as projects, just like we did this one. Import CSS projects, and then you can actually use your error to find where it's at with an exception. See, when Code Composer Studio looks for the library, it's looking in the binary folder. Remember when we imported this gpioLED project, we looked in the build folder, and that's where we want to look for our projects to build. We want to look in the build folder, and then when we build them, it will end up in the binary folder, and that's where the program will go to look for them to include them in our other projects. So we're going to go look at, let's see, ARM v7a, blah, 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 blah. Okay, I've done this a few times, so I think I can remember that. Yeah, here we go. It's on my computer, my C drive, down here under TI, and then it's under here. That's their StarterWare package. Look in build, not in binary. ARM v7a, CGT underscore CCS, and the AM335 BeagleBone drivers. That's the first one we want, drivers. Okay, make sure these are not checked, and then import them. And you're going to do the same thing for the other files that are missing. So there's actually also the system config, and the platform, and the utils. I'm going to go ahead and do that real quick, and I won't talk a whole lot about it. Just going to import them one at a time. Platform. Make sure platform's checked. Make sure those are not checked. Finish. What else did I say? System config. System config. And utilities, or utils, right here. Now, once you build these the first time, you shouldn't have to build them again. It's just the first time you use them, you need to build them. And this is something that kind of stumped me for a little while, because other products I've used from other suppliers, when they include their pre-built libraries, well, they come pre-built. So I'm also going to refactor these, make sure that we're using the right compiler and everything. You can check properties, but I know that they work as is. It just it comes in as a generic Cortex A8 device, and that seems to work. So we'll keep that, and then one at a time we'll go ahead and build these projects. Yes, same thing, refactor, build. Now you might want to check the properties in each one, but I've already done this a few times. I know that they come in okay to use. And so you can also hit the hammer here if you don't want to right click. Okay, now once all those are built, then you should be able to build your main project that you wanted to build. And we'll go ahead and do that. And so now we've built all the projects and all the dependency projects, and now it's time we can go ahead and program the device. Okay, before we plug in the BeagleBone, first we want to plug in the JTAG emulator into the computer so that it can load the drivers. And when you installed Code Composer Studio, you would have had an opportunity to select which interface you're going to use, and make sure you select the one that I referred to, and assuming that you're using that one. And you can go ahead and plug it, and it'll install drivers. I've already plugged it in, and I've already installed the drivers, so it's not going to show you anything here, but just make sure that you plug it in your computer first before you plug it into the BeagleBone, and you do have to have Code Composer Studio installed before you can install the JTAG interface. So let's go ahead and switch to the other camera, and we'll plug in the JTAG to the BeagleBone. Okay, here we have the BeagleBone Black, and as I mentioned earlier, I've installed a JTAG header right here, and notice that pin 6 is not present. When I bought this, the actual ones called out in the tutorial that I'm going to link to wasn't available. But there was an alternative. It did have pin 6 installed, and it's pretty easy. Just use a pair of pliers to pull pin 6 out before you solder it to the board. So make sure pin 6 is not present, or bad things might happen. And here is our JTAG emulator. This is Blackhawk USB 100V2, and this connector, the edge with the red stripe is going to go towards pin 1 here, or I'm sorry, pin 1's over here, but still it's going to go towards the edge of the board. Make sure you get it on the right way. You don't want to put it on backwards. If my hands would stop shaking. There we go. Installed. Okay, I'll turn that around so you can see it. And so this program is going to blink one of these LEDs here, and you'll see how that works here just in a minute. Now when you power up the BeagleBone with in this way, we need to hold down the user boot button while we plug it in, so that it doesn't boot the operating system. You can see that I'm holding down this button as I plug it in, and once it's plugged in, then I can release it just like that. doesn't slide off the table. Okay, now that we have it plugged in, we can go ahead and program it. So we'll want to hit the debug, and it should give me an option here. Oh, it didn't do it because I must have done this before, but when you do this for the first time, it will give you a couple options, and make sure that you uncheck the interface that does not apply and check the one that does apply. So I guess I can't explain it more than that, but you should only have one checked when it gives you the option when you do that. Okay, so now it has loaded the program, and just to give you a little tour here, and this might be a little bit different depending on how you have your stuff set up, but this is what's really cool about using the JTAG, is we can go in there and look at the value of every register on the board. So here's our main core processor and all the register values, and I can go ahead and step through this. Let's do just do this. And you can see how these values change as I step through the program. This is going through line by line of the code as I hit this, and the values are changing in the processor. Now that's just fine, but I'm just going to hit this resume button, and I'll go ahead and just run the program. And you'll see, and these won't refresh while it's running like that. Yeah, but now you can see that the LED is blinking, and so I can hit stop there, and I can hit debug again. Yeah, and so then we can go down and we can look through our registers and yeah, just do whatever we want here, and just step through the program. And if you have something that's not working right, you can use this to navigate down through your different values to see what's actually happening in the program. And that's what's really nice about having the JTAG. You can see what the values are anywhere on the chip. So that's about it. Hope you liked this video. Please subscribe, like, comment. If there's something here that I could improve on in terms of how I'm doing things, please post a comment. I'm certainly not an expert at the BeagleBone yet, but if we just post a comment if you have something to contribute. Okay, so that's about it. I hope you liked this video. Please subscribe, comment, like the video, share, and we will talk again real soon. You know what we'll do in the next video is we'll actually take out the delays here. Okay, so that's about it. In the next video, I'm going to take out these delays in here, and then we'll measure how fast this thing can toggle that pin on that GPIO pin. Something I like to do just to kind of get an idea for performance. So using the libraries that are provided here in the StarterWare, we'll see how fast this can run. So that's about it. I hope you liked this video. Please subscribe, comment, share. Let me know anything that you think, that if you have different ideas on how we could do this better, please share with everybody. So we'll talk again real soon.